Okay, guys, the other day we had our Unit 1 quiz. Some of us did excellent, and some of us did not do so well. Please pay attention today while we do this. We're going to do a Unit 1 review. I'm going to talk about three different problems and work through them. These are three problems we struggled with. Make sure you pay attention, and then at the end, you're going to have three more problems to solve. If you get those right and submit them, you're going to get points on your quiz. So you need to do this. Please pay attention. First type of problem we're talking about is ordering real numbers. In this example, we're going to take and order them, put them in ascending order. Well, we need to mark on our paper that ascending order means least to greatest. So least to greatest. And make sure you're copying this down with me. You can pause it at any time if I'm moving too fast, but make sure you copy this down. Your teacher, me, whoever your teacher is, will want to see this, okay? Put this in your notes, Unit 1 review. You can actually put it as a journal entry if you need to. So ascending means least to greatest. What I did first was I went ahead and made my T-chart. I have my original and my decimal, because that's what we do. We convert everything into decimals. So the first thing I'm going to do, and I'm going to use my old trusty calculator. You might be able to see that. I don't know. I guess you can. I'm going to do the square root of 17. Now, when you guys get back to school, we will be using these types of calculators, and I will show you how to use those. I got 4.123 something something. I'm not going to write all that out. I'm going to make it look like money and stop at 4.12. Negative 1/3 is next, so I'm going to do negative 1 divided by 3, and I get a bunch of negative 0.3s. I'm lazy, so I'm going to put a 3 with a line over it. 4 1/2, that's a mixed number. You know, a lot of kids don't know how to make this into a decimal. It's real simple, guys. You cover up the 4. You do the fraction. 1 divided by 2 is 0.5. Then you put the 4 back in front of it. Ooh, that was tough. I don't know how many kids ask me, I don't know what to do. Ignore the whole number for a minute and just do the decimal, goofballs. Hey, that one's already done for us. We don't have any work. Uh-oh, be very careful with this one. We got square root of 9 over 2, but the fraction bar and the 2 are not in the square root symbol. So I'm going to find my square root, and on here it's the second key, and that key, there's my square root. I'm going to plug in my 9. I don't want anything else in there, so I'm moving out, and I'm dividing by 2. And I got 1.5. Okay. There is my decimals. There are my decimals. Now, Mr. Fraley has told you, and you better always listen to Mr. Fraley, that you need to make all your decimals the same length. If you make them the same length, you can look at them like normal numbers, easy numbers. So this guy's got 1 in front. Don't worry about what's in front because those are whole, but worry about how many digits in the back. So I got 2 digits in the back, 1, 1, 1, 1. Everything's going to have 2 digits. So I'm going to go down here and add a digit behind this. So it's a 5. It's not repeating. I can add a 0. This guy's not repeating, so I can add a 0. This guy's not repeating, so I can add a 0. This guy is repeating, so I'm going to add what's repeating, which is a 3. All right? So now they're all the same length, and guys, honestly, they look like money. So if I want to start with the smallest numbers, you know the smallest numbers are always going to be your negative numbers. And we need to be real careful because the smallest negative doesn't look the smallest. The smallest negative looks like the largest number. So that's negative 1.6. Then after that is negative 1/3. Then after that, we go to the smallest positive. So we're thinking correctly again. We're not reversing our thinking, which is square root of 9 over 2, $1.50. Then we got $4.12, which is the square root of 17. And then we've got $4.50, which was 4 1/2. And there's my answer. Next thing we're going to talk about is approximating irrational numbers. Now, this statement is read 1/5, that's an inequality symbol. It says 1/5 is less than x, but x is less than 3/8. What I want you to do is draw a number line and put the two original numbers on your number line. Here's 1/5, here's 3/8. And just know that this really means that we're looking for one of these numbers that goes in the middle. We want the one that goes in the middle. That's what we're looking for, okay? So we got to convert these guys to decimals first. And when I do that, I do 1 divided by 5. I get 0.2. I'm going to put 0.2 up here. I'm going to put my decimal values up there. 3 divided by 8. Oh my gosh, that gave me a weird number. That gave me 0.375. Okay. And then we're going to go ahead and convert all of our answer choices. So let's take 3%. 3%, you would divide it by 100, and that would give you 0.03. And how about if I write it over here so you can see it better? And then 2/5, if I divide that, gives me 0.4. 3/10, if I divide that, gives me 0.3. And 0.51 with a line over it is already decimal. So 0.51, a line over. That's weird. We're going to come back to that. Now, guys, again, with decimals, we want them to all be the same length. Well, let's find the longest one, and I believe it's this guy. He's got 3 digits. I need all of them to have 3 digits. Start with him. I'm going to add 2 zeros. Now, let's go to this guy. He needs another digit. Nothing's repeating. Add a 0. It looks weird, but it's really 30. He's not repeating. He needs 2 digits, so add 2 zeros. He's not repeating. He needs 2 digits. Add 2 zeros. He is repeating. Now look at the line. The line's actually going over the 5 and the 1. You know what that means? Both numbers repeat in that same order. So he only needs 1 more digit. So the next number to repeat would be a 5. If I had to go again, it would be a 1, then a 5, then a 1, then a 5, then a 1. So now they all got 3 digits. Now I look for the one that goes in the middle. Well, 30. 30 is not in the middle. No, 30 is way over here. So it's not 3%. Cross them out. 2/5 or 400. 400 is, oh no, it went past the middle. 400's here. So it's not 2/5. 3/10 is 300. Okay, so 300, 200. Oh, wait a minute. That might be it. That might be it. Put 300 here, and that's actually 3/10. Let's see. We think it's this one. 515. Well, no, it's definitely not that. 515 is way over here. Ugh, I can't even write it. I'm running out of room. It's way over here. And so it's not 0.51. So the correct answer is C. Last one, then it's going to be your turn. Scientific notation. I don't know why we struggle with this, but let me give you some advice. If I'm writing this in scientific notation, here's one thing you need to know. An example of scientific notation would be 3.1 times 10 to the 4th. Or you could have a negative 3.9 times 10 to the negative 3rd. These are both good examples. The problem is when you get bad examples like this or this. What do you notice different about the good examples and the bad ones? Well, how many digits are in front of the decimal point? 1. How many digits are in front of the decimal point? 1. And they can't be zeros. They have to be 1 through 9 as a digit, okay? I don't even see the decimal point here, which means it's there, and that means there's 2. So that's why that's wrong. It can only have 1. This one's got nothing nothing in front of the decimal point. So that's not right either. You got to have one digit in front. Well, if that's the case, we're going to move this decimal point, and I move it to where there's only one digit in front, which is right there. So let's count by doing our little loop-de-s. 1, 2, 3, and 4. I moved my decimal point 4 places. So my new number is 3.81. Again, I got one number in front. And we said we moved it 4 places. Now, the problem's going to be, is this supposed to be a positive or negative exponent? Well, I want you to think about it from here. If I take 3 point something and multiply it by a positive, that should make it grow and get a bigger number. But that was really a small number. It was little. It was 0.000 something, which means that it's not positive, which means it should be a negative. Because when you think about it, I think, hey, if I multiply 3 point something times a negative, that should make my value get smaller. And this was a very small value compared to that. So that's how you always check, okay? This is now your turn. So here's what I need